In this video, we're going to show how to do a simplified trade-off between mechanical and envelope. Let's say that we have a building that has exposed brick and the design team just wants to keep the exposed brick. Or let's say we're going from semi-heated to fully heated and we have to change the HVAC. Per code, any change in the heating system requires the envelope to be brought up to current thermal resistance. However, if we can show that we are saving more energy with a superior mechanical than we are losing through the inferior envelope, then we have demonstrated that we have met the intent of the code. We are using less energy than a building built to prescriptive standards. In this example, we'll look at a facility where we are going from, it's a retail space, open from 7 a.m. to 7 p.m. And let's say the code minimum design we want to consider is a natural gas 80% efficient, and we want to go to inverter driven heat pumps. That system will require a DOAS, a dedicated outside air system, and you can buy your dedicated outside air systems with heat recovery and with demand control ventilation. And in this case, we are open from 7 a.m. to 7 p.m. Since we have demand control ventilation, we can take advantage of the ASHRAE occupant densities. What we'll do is we'll price out the baseline, the heat pumps, for a 10-ton heat pump, $25,000. For the inverter-driven heat pump with the DOAS, let's say that's $40,000. The difference in cost is $15,000. Well, looking at the energy savings attributed only to the ventilation portion of what the mechanical system serves, we have about a 20-year payback. And that's going to be a hard sale. So let's also look at the energy savings from the higher efficiency mechanical equipment as it handles the heat loss through the envelope. In this tool, we have the ability to model our envelope. We can have two wall assemblies. We can have our mass walls, our metal framed walls, our floors, our windows, and we select the construction type for each of these assemblies. And in this case, what we have is about 1,500 square foot of non-furred out R0. And you can see we have loads of assemblies for you to pick from, or you can do your user defined. And the area of it, and it shows you the deficiency. Our roof insulation, we want to just stay with the R20, and that's a little deficient. On our windows, we don't want to upgrade those. Those are deficient, but they are already double pane. They just don't have the solar heat gain. So now that we've selected our envelope, we hit calculate, and we find that we are in fact using more energy through that envelope because it doesn't meet code, but we're more than compensating for that with our mechanical system. If to fur out the walls, so therefore we have a code compliant design. Now let's look at the payback. If to fur out the walls, it costs $10,000, and not to mention the disruption to the tenants. And we saw earlier that our cost for the superior mechanical was $15,000 more, the avoided costs. We find that the payback now is only 6 years. So the owner might look at that and say, you know, I am going to save energy in the long run, in this case about $840 a year, but I might lose money with having to disrupt my tenants. So this makes sense. I will go with this. I would prefer the superior mechanical system over the code compliant envelope.